All right, level 2 inequalities. Okay, so remember when you are solving an inequality, you solve it just like an equation, only you have to be extra careful to keep track of this inequality symbol because it could flip along the way and it changes your solution completely. We're not just after a number anymore, we're after a whole set of numbers. Okay, and so this alligator is facing this way right now, and we are going to keep track of him the whole way. And so the first step to solving is, let's go ahead and distribute so we can simplify each side. And so 25 on the left, this becomes 15 minus 6y after the distribution, and then we still have a plus 5 that was outside the parentheses. And so now we can combine some like terms. This 15 can combine with this 5. And so that would make 20. Remember, we don't change any signs unless we are isolating. We aren't doing that yet. We are just combining like terms. Now we are ready to isolate the y. And so to do that, we have to get rid of this positive 20 first by subtracting, leaving us with just this negative 6y. Don't lose that negative because now here we have to divide by the negative 6. And when we do that, it flips. Anytime you multiply or divide by a negative, it flips your inequality. And so now my solution, or solutions, has a y, and then we have a negative 5, 6 over here. Notice the flipped inequality. Now to graph this solution set, it's always easier if you put the variable on the left side. Right now, the variable is on the right, so I'm going to write it on the left. And notice this alligator is facing the y, he's eating the y, so I gotta preserve that. And then our negative 5, 6. This expression and this expression say the same thing. Y is the bigger of the two. And so to put this on our graph, we're going to put the negative 5, 6. I would just put it right in the middle. Negative 5, 6. If we were to put 0 on here, he would be over here. And I am using an open circle because there is no line here. And so because y is greater, the greater numbers are this way, towards positive infinity. And so this would be the graph of our solution set. And so positive 1 would be a solution. Positive 2 would be a solution. Even negative 0.5 would be a solution. And so anything greater than negative 5, 6 would be part of our solution set. And so a test question could ask for this, or it could ask for this graph, this purple graph I have here. Okay, here we've got variables on both sides, but we still treat it just like we treat equations. And so we're going to keep track of this inequality the whole way. And so there's nothing to simplify, so we're ready to go ahead and combine, not combine, but get all of our a's on one side. And so I am going to go ahead and take away 2a from both sides, leaving me with a 1 on the left and a 4a plus 11 on the right. Next, I'm going to isolate the a. So a is right here, and so we need to get rid of the 11 first because it's not attached. So subtract 11, leaving me with a negative 10 on the left. Draw the inequality symbol, and a 4a on the right. Now we can divide by the 4. And since I am dividing by a positive number, I do not flip this inequality. And so negative 10 over 4 is the exact same thing as negative 5 over 2, or negative 2.5. And then the 4's canceled. And so now remember, when we're writing our solution, we always want to write the variable on the left, the number on the right, and since this was facing the A, it still has to face the A. And so when I graph this, I want to put negative 5/2 on my graph. Put it right here. And then again, we have an open circle since there's no line. And it's greater than, and so the numbers greater than negative 5/2 would be 0, 1, all the positive numbers all the way to positive infinity. So that's to the right. Greater than's to the right. Another way you could solve this is, I'm going to solve it again in purple. And so if I have 2a plus 1, 6a plus 11. If I were to have subtracted 6a from both sides, I would have had a negative 4a. And then 11 on the right. And then I would subtract 1. And then here at this step, instead of dividing by this positive 4, we would be dividing by a negative 4. And then that would cause our inequality to flip. And so our solution would have an A on the left, a flipped inequality, and then 10 divided by negative 4 is negative 5/2. And so here the variable is already on the left, so that makes it nice. But we had to remember to flip the inequality because we had a negative. In the blue situation, we were dividing by a positive, so we didn't have to worry about flipping the inequality, but we had to be sure to rewrite our answer with the variable on the left before we put it on our graph. And so in both cases, I get A is greater than negative 5/2. If you want to avoid negatives and follow the blue steps, that's great. Just remember to write your variable on the left at the end. Or if you don't mind working with negatives, you have to remember to flip your inequality when you divide by that negative. Anytime you multiply or divide by a negative, you have to flip your inequality. If you divide by a positive, you do not flip. All right, here we need to go ahead and distribute. And then there are no terms to combine, so we're ready to put our ends together. I'm going to keep the variable on the left this time, and so I'm going to subtract 6n, leaving me with negative 2n. Then I'm ready to add 4. And then divide by a negative. And so because we're dividing by this negative, my inequality flips. Negative 8 divided by negative 2 is a positive 4. So anytime you're solving an inequality, the inequality symbol is only going to flip one time, and it's always going to be in the last step, because that's when we're multiplying or dividing by a negative in the last step. So one flip per problem, and it happens in the last step. And so now, since I kept the variable on the left, I am ready to graph this. It's a positive 4, so if here's 0, 1, 2, 3, 4, we would have a closed circle here, because this time we do have the line. If you take the time to draw this line, take the time to color in your circle. And this says greater than, so it's off to positive infinity. All right, getting more challenging. So I see some parentheses telling me I need to distribute. Notice I'm circling the negative with the 2 because that is a negative 2 we are distributing. A lot of people lose that. So that becomes negative 2d, and then negative 2 times this negative 1 is positive 2. I still have this 11 that I haven't done anything with. And then now I have some like terms I can combine. (11 plus 2, don't change signs, we're just cleaning things up right now, is a 13. And some of you may be noticing something funny about this problem, but I'm going to keep going. And so now that we've cleaned up both sides, we're ready to get the d variable on one side. So I'm going to add 2d, add 2d, and notice the variable gets canceled on both sides, leaving me with a 13 on the left and a 13 on the right. Okay, and so this is a special case. Anytime your variable drops out of your equation or your inequality, it's one of your special cases. And so you have to look at what's left behind. And so I'm going to highlight that in yellow. 13 is greater than or equal to 13. I have to decide if that is true or false. Well, since 13 is actually equal to 13, this is true. If that line wasn't underneath the inequality, that would be false because 13 is not greater than 13, it's equal to. And so the line here saves it. And so because this is true, our solution is all real numbers. If it were false, we would say no solution. So true means all real numbers, and so I'm shading the entire number line. We can use the fancy R for our solution, or you can write it out. Okay, so remember true, that means all real numbers. False would mean no solution. And that's it. So, yeah, that's it.